Okay, I've been getting a number of questions on this Newman projection problem from your test practice packet too. So I wanted to explain it on a video. I think that will be more helpful for you. So first, let's take this bond line formula and draw in the bonds that aren't shown because it will help you convert it to Newman much more easily. So right here, we need to draw in an H on a wedge. And over here, we need to draw in an H on a dash. Okay, now they're instructing us to look down the carbon-carbon bond at this point, okay? So this is a 4-carbon structure. We're looking down carbon 2, carbon 3 at this point. So what we need to do is imagine that we're taking the structure and we're flipping it to the left out of the plane of the screen. So if we look at this front carbon, we have one bond going upwards and two bonds going downwards. So when we draw this to Newman, we're going to have an upside down Y for the front carbon. And this bond going upwards is going to be our methyl group. This bond on a wedge is going to be our chlorine group. Remember, we're flipping the structure to the left. So anything that's on a wedge is going to also be on the left. Now, this hydrogen that's on the dash is going to be on the right. Okay? So let's just take a second and compare this front carbon to the answer choices that we have given to us. We'll notice CH3, chlorine, hydrogen, in the same order as we have in our drawn Newman projection. Same thing with answer number 2, CH3, chlorine, and hydrogen. The other two don't have that order, so you can automatically eliminate them, okay? They're going the opposite direction, so forget those. Now, if we look at the back carbon is going to be expressed by a circle, and you'll notice the difference here. We have two bonds going upwards and one bond going downwards, so on the back we should draw a Y, and that's what I'm doing here. Now remember that anything on the wedge, because we flipped the structure, the whole thing to the left, anything on the wedge is going to be on the left. Anything on the dash, the methyl, is going to be on the right. And then this downwards bond, bromine, is right here. Now, we have to choose between answers 1 and 2. If we look at answer 2, you'll notice that it doesn't quite have the same positioning in the back carbon. However, quick shortcut, we're noticing methyl goes to bromine, goes to hydrogen in a clockwise fashion, okay? If we look at our structure, methyl to bromine to hydrogen is also clockwise. This is the same answer, okay? Now, if you don't believe me, what you can do is rotate the back carbon 120 degrees counterclockwise, and you will produce the same exact Newman projection as what's drawn on the screen here in number 2, okay? So if we rotate the back carbon 120 degrees counterclockwise, the methyl will go where the H is, the H will go where the bromine was, the bromine will go where the methyl was. So let's draw that out right here. Front carbon is still the same, methyl, chlorine, hydrogen, okay? Now the carbon in the back, everything is going to have shifted 120 degrees. So this bond right here will be our methyl. So methyl went here, H went where bromine was, that's down here, and bromine went where the methyl was, that's here. And if you compare this and you compare this, they are identical, okay? So that's how you solve this problem. I hope that was helpful. I will hopefully have clarified any errors that you were making before, okay? Bye-bye.